Okay, hanggang dito, Ineng, ito yung last. Okay, okay,
Apo.
good. Okay, so this yield strength is another mechanical property, and this stated dito po sa figure na ito, we could say that only metals and polymers has these values of yield strength since they are considered as ductile material, whereas the ceramics, naka-indicate po dito, it is hard to measure since in tension, okay, fracture usually occurs before the yield, okay? So, ganun din po ang nakalagay po dito sa atin ng composite, okay? The fracture usually occurs before the yield since they are brittle materials, okay? Kaya po, walang yield strength, okay? So let us go to another mechanical property. So we call it the tensile strength. Okay, so for the tensile strength, okay, you can call it also as the ultimate strength. Okay, so ang tawag po sa kanya, it can be a tensile strength, it can be an ultimate strength, o kaya naman po ay ultimate tensile strength. Okay, so pare-pareha po yung tatlo. Okay, ultimate strength, ultimate tensile strength, at saka po tensile strength. Okay, so ano nga po ulit ito? On our stress strain diagram, this is the highest point. Okay, so it will be the highest point on your stress strain diagram. Okay, and we say this is the maximum stress that a material can hold without the fracture. Okay, and beyond this value, nandun na po yung rupture. Okay, so this maximum stress, okay, again, it is the highest stress on the engineering stress strain curve, okay? And here on the illustration, you would see here our test specimen, okay? So this is our original test specimen. So ano po masasabi natin sa original test specimen? You have there the diameter, you have the gauge length. And then you apply yung load. So within this area, okay, ito po yung atin na elastic behavior. Okay, wherein if you load this with a force, it will have its deformation. Then when unload, it would go back to its original dimension. Okay, so yun po yung nangyayari doon sa test specimen po natin. And then see that yung nagiging changes po sa ating specimen as you go along with your testing. Ano po ang nangyayari? Okay, so mapapansin po natin, there is appreciable deformation. Okay, nagkakaroon na po siya ng elongation. Okay, so if you compare this with this one, so mas nag-elongate na po siya, and at the same time po, mas na-reduce naman po yung kanyang cross section. Okay? Until such time, nagkaka-build na po ng neck. Okay? And then at this point po, diyan na nagkaroon ng putol. Okay? So once po naputol, dun po natin i-measure. This would be the final diameter of your specimen. Okay? And that would be used in solving for the final area. Okay? So yan po yung nangyayari within the test po na kinukonduct natin on a tensile test. Okay? Okay, so this is the comparison between the tensile strength of the materials, okay? Different material classes. So again, these are for metals, at blue is for ceramics, green is for the polymers, and composites po itong color pink, okay? So as you can see here, the tensile strength naman po, pinakamababa po dito sa polymers, okay? So mababa lang po yung value ng kanyang ultimate strength, not unlike that of a metal. So kung titingnan niyo po sa mga mechanical properties, if we have the comparison of the different mechanical properties, it will always be the metals who has yung superior properties over the other. Okay? So, ganun pa rin po yung pagbasa dito. Halimbawa po, you're asked to find the value of yung concrete. What will be the tensile strength of the concrete? So, you have here po yung concrete po natin. So, titingnan lang po natin yung reading po dito. So, approximately 40 megapascal is the value. Okay? Yan. So this is another mechanical property. You call it the ductility. Okay. So ductility may be expressed into two. Okay. Ductility can be expressed in percentage elongation. Okay. So percentage elongation, and the other one is percentage reduction in area. Okay? So, pwede po natin express yung ductility ng material based on these two. Okay? So, if you are to compute for the percentage elongation, ito po yung equation natin. Percentage elongation equal to LF minus LO over LO times 100%. Okay? LF being the final length and LO is the original length. Okay? So this can be stated as the deformation, okay, over the original length times 100. Okay? Or this is simply equal to your strain times 100%. Okay? Yan po yung percentage elongation. Okay? At pag sinabi naman po natin ductility in terms of the percentage reduction in area, percent RA will be AO minus AF over AO times 100%. AO is the original area. So kung ito po yung specimen natin, what would be the original area of the member? Okay, so that is, kung siya po ay rod, you make use of the original diameter, pi d squared over 4. Okay? Tapos yun po namang final, we'll make use of the final diameter df. Okay? So paano po malalaman yung final df? So sa experiment po natin, ang gagawin po doon, okay, doon po sa pinagputulan, doon ka po magme-measure. Ang gawin nyo po, pagdudugtungin muna po ulit ninyo, tapos doon nyo po i-measure using your caliper, okay, to find the final diameter, okay? And the area, of course, would be equal to pi d squared divided by 4. Okay? So, you use here only the original diameter at dito naman po yung final diameter kung saan nagkaroon po ng fracture. Okay? So, again, your ductility may be expressed in two ways. Una, in terms of the percent elongation, and then the other one would be the percent reduction in the area. Okay? So, you take note of these equations po. Okay? And the value or the unit for this po are both in percentage. Okay? Now, dito naman po, makikita po naman natin is another stress strain diagram. Okay? And using this stress strain diagram, pwede po graphically, you can obtain the ductility. Okay? Para po yung yung kahapon, ang ginawa natin on the yield point. Okay? So, graphically, we determine po the yield point. Paano nga po ba kuhanan yung yield point? Okay? So, you'll have there a strain offset of 0.002. Tapos, using your straight edge, gagawa po tayo ng parallel line to the linear elastic region, okay, katulad po nito. And then, kung saan po siya mag-tangent doon sa curve, yun po yung ating magiging yield point. Okay, so yun po yung kahapon. Ngayon naman po, using the graphical method, we obtain po the ductility. Okay, so paano po kukunin yung ductility? Ductility is simply equal to the area under the curve, okay, the stress strain curve. Okay, so halimbawa po, ito po yung stress strain curve natin, yung color green. Okay, so kung ito po yung stress strain curve natin, the area below that would be equal to your ductility. Okay, so alin po yung area na yon? Ang gagawin nyo po, kukunin mo muna po yung last point, which is the breaking point or the rupture strength. Okay, so yan po yung rupture strength natin, yung point na yon. Ang gagawin po natin using a straight edge, okay, atin po ulit gagawa tayo ng parallel line to this. Again, this is your linear elastic behavior, okay, or region. So, this is your linear elastic region. So, gagawa po tayo ng parallel line dito, okay, dito sa straight line na to, passing through your rupture strength. Okay, so ito po yon. Okay, so this is the parallel line passing through your rupture strength, parallel po doon. Okay? So, ito pong area bounded, okay, noon pong dalawang na yun, okay, dalawang lines po na yun, yan po yung ating ductility. Okay? So, the area below the curve, okay, yan po yung ating na ductility. So, how do you obtain this area po? Okay, that is using integral calculus po. Okay, integration. So, kailangan lang po natin dyan, we should know the equation of the curve. Ano ba yung equation ng curve na yan? And then, kuha po tayo ng differential strain. Okay, so ito po yung differential strain. Okay, so, yung pong equation of the curve, D straight. Okay, so yun po yung ating magiging equation po doon. And then you take the integral of it to obtain this area. Okay, so pakirecall lang po natin. Okay, again, pakirecall lang po natin yung ating integral calculus. And then you apply limit. So ano yung magiging limit natin? It would start from 0, 0 up to kung ano pong value ng strain po na ito. Okay, so yan po yung magiging ano natin for this ductility graphical method po. Again, kailangan po alam natin ang equation po nito, tapos you have here differential strain, okay, to obtain the ductility. Again, it is the area below your stress strain diagram. Okay, so you have here naman po another property, you call it toughness. Okay, so anong difference nito from the ductility? So this one is the energy to break a unit volume of material. Again, it is approximate by the area under the stress strain curve. Okay, so kung sinabi po natin yun, parang parehas lang po kanina siya ng ductility. So ano pong pinagkaiba ng toughness with the ductility? Okay, so kanina po, consider natin na stress strain diagram, ayun pong color green. Okay, so ano po yung color green? Okay, so this is for metals. Okay, so ano pong sabi natin? This is the area under the stress strain curve. So ito po yung area under niya. Ano lang po yung pinakaiba niya with that of the ductility? Ano pong pinakaiba? Again, you go to the rupture strength. This is your rupture strength. Okay? Ano lang po ang gagawin doon sa rupture strength? You simply draw a vertical line. Okay? You simply draw a vertical line passing through your rupture strength. Okay? So, that encloses po yung region below your stress strain curve. So, ito po yung area ngayon. So, ito po ngayon yung area involved para sa toughness. Okay? So, ito po mismo itong area na yan po yung equal sa toughness. Okay? And if you are to compare that with yung ductility, okay, ito po naman siya yung ductility. Ano po kaya ang difference niya? Looking at these two illustrations, this is the area below the curve. Okay? Ito po yung curve, tapos below, this is the area. Okay? And this one naman po is your toughness. Okay? Yun din po. Ito din po yung area niya. Okay? Below the stress strain curve. Ano po yung pinagkaiba? Anyone po? Sino pong nakakita ng difference? Hello? Sino pong nakakita ng difference sa dalawa? Toughness over that of brittle. Okay? Ano po yung ductility? Ito po yung area below. Okay, ito po yung ductility. Yan. So, ito po yung nasasakop niya. Yung area po na yan. Okay? And you look at yung toughness. Okay? So, ito naman po yung toughness. Ito naman po siya. The area below this. Ano po ang pinagkaiba? Hello? Anyone po? Narinig po ba ako? Yes, Janela.
Siguro po ay mas larger po yung area ng toughness compared po sa ductility po kasi naka-parallel line po yung sa which is dalawang line po yung naglilimit, and then dito naman po sa area po ng toughness ay parang
okay, correct po si Miss Janela. Okay, kanina kasi yun pong ating ductility, okay, with regards to the rupture strength, okay, yung limit niya would be itong parallel line to the linear elastic region. Ito po yun, tsaka po ito, okay. Ito ngayon, ginawa lang natin na vertical, okay. So, ito kanina, if you have this, parallel po dito, okay, so it would be parallel to this, passing to the rupture strength, okay. So, ito yung kanina. Okay? So, ito po yung ductility. Okay? Yan. So, ito yung ductility kanina. Okay? Hanggang dito. Hanggang dito lang. Okay? So, ngayon po, kapag toughness, it is bigger than this amount. Okay? So, alin ang ibinigay na amount na mas napalaki? Ito. Okay? So, mas malaki po yung toughness as compared to that of a ductility. Nakita po ba yung difference? Hello?
Ilang percent na po ng sabon?
Hello?
Yes, po.
Okay, since both are the area below or under the stress strain curve. Okay, so magkaiba pa din. Okay, kasi ito, parallel to the linear elastic region, yung isa naman is simply a vertical line. So, covering all this area under the stress strain curve. Okay, so yun po yung difference. Oh, this is the other one. Okay, so ito naman po, ang tawag naman po sa kanya is resilience. Okay, so for symbol of resilience, you have their U subscript R. This is the ability of a material to store energy. Okay, so energy is stored best in the elastic region. So paano po natin malalaman yung resilience? So ganun pa rin po, siya po ay area under the stress strain curve. Okay, kaya lang po, hindi siya total area yung stress strain curve. Ang unang muna po natin hahanapin would be yung sigma y. Okay? So you look for the yield strength. Okay? So paano nga po ulit yung yield strength? From 0.00, okay? So i-measure po natin yung strain na 0.002. Okay? So you look at a strain of 0.002. Tapos, using a straight edge, again, you draw a line, okay, parallel to the linear elastic region, okay, passing this 3.002 and parallel to the linear elastic region. So, parallel po dito. So, this one, okay? And then, kung saan po siya mag-tangent with your stress strain curve, yun po yung value ng atin na sigma y, okay? And pag nakita mo na po yung sigma y na yun, okay, the area under po, no, hanggang doon sa sigma y on your stress strain curve, yun po ang value ng resilience. So you will be simply drawing a vertical line, okay, and this area below that would be your resilience, okay. So if you are to compare the three, resilience, you have their ductility, and the other one is toughness, okay? So, resilience would be the least ang value, okay? Followed by yung ductility, and then pinakamataas po is the toughness, okay? So, yan po yung graphical representation po niya, okay? Paano po natin makikita yung hangganan? You have to determine the yield strength, okay? Yung pong atin na sigma y. Again, graphically, yan po lang kukunin natin. An offset strain of 0.002, and then we have there yung parallel line. Okay? Para po ma-meet po natin yung value po na iyon. Okay? May question po ba tayo doon? And then in equation form naman po, you can compute for the resilience. Okay? The resilience equal to 1/2 sigma y times the strain y. Okay? Again, resilience UR is approximately equal to 1/2 of sigma y times the strain y. Okay? So let us apply it here po on our sample problem 3. Okay? So, atin lang po tandaan, UR equal to 1/2 sigma y times the strain y. Okay? So, yun po yung ating equation for the resilience. Okay, so steel springs must have a modulus of resilience of at least 2 megapascal. What should be the minimum yield strength in megapascal of a 10 millimeter diameter spring used to support a load of 10,000 Newton if elongation is 1 millimeter for every 100 millimeter length? Okay, so ang hahanapin po natin dito, okay, is the minimum yield strength. Okay, so given the modulus of resilience, okay, UR is equal to 1/2 sigma y times strain y. Okay, so ito lang po ang kailangan natin. And you are asked to find, okay, the minimum yield strength. So you are to find this value of sigma y. What should be the value of sigma y? So necessary that you know the modulus of resilience, UR, and the value of the strain y. Okay? So saan ko po makukuha yung strain y? Strain is simply equal to the change in length, okay, or the deformation over the original length. Okay, so ito lang po yun. So you identify here, alin ba yung deformation, okay, at alin po yung original length. Okay, nakuha po ba kung paano gagawin? Hello? You try to solve po sample problem 3. Okay? So we'd start with the equation of the modulus of resilience. U are equal to what half times sigma y times strain y. Okay? And this value of strain would be equal to the deformation over the original length. Okay? So once you obtain this value po, this is your sigma y. Okay? And then you are to find po aring sigma y. UR is already given. Okay? So ito po i-divide mo lang doon and then you have there times 2 to obtain your sigma y. Okay? Nakuha po. Pakisolve nga po natin. Tingnan po natin kung ano yung sagot. So there are those values that are written here on our problem 3. Let us try to identify. First, modulus of resilience of at least 2 megapascal. So, ari po yung atin na UR. Okay? 2 megapascal. What should be the minimum yield strength of a 10 millimeter diameter spring? Okay? Ito po yung diameter. Okay? Used to support a load F of 10,000 Newton. Okay, if elongation is 1 mm, okay, so this is the elongation for every 100 millimeter length, that is the original length. Okay, so yan po yung mga gagamitin po natin. Again, you start your solution with UR, 1/2 sigma y times the strain y. Okay, UR is already given. Sigma y po, may given po bang sigma y? Okay, so this is what we are looking for. And then you have there yung strain y. Okay, strain y is simply equal to
5 factorial naman, ate.
deformation over the original length. So what is the deformation? The deformation is the
5
elongation.
factorial.
So this is 1 mm. And what is the original length? 100 mm. Okay? So you can obtain the value of your sigma y para po siyang i-substitute natin dito. So therefore, po, yung UR or the modulus of resilience, okay, you can solve it na po. Okay? So there are those values here or given that are not really used in this problem. Okay? So inilalagay lang po yun para pampalitin po sa atin. Akala po kasi natin, lahat ng given, dapat lahat ay gamitin. Okay, may question po ba? Pakikuha nga po ng sagot natin dito for the value of your answer po for problem 3. Okay, so I'll again have here po ang ating Jamboard para I can see your work po. Okay, you can now join po yung ating Jamboard, okay, for you to place your answer. Ito na po yung flow ng ating solution, okay? So you have there, UR equal to 1/2 sigma y times string y. So you solve for string y, and later, i-substitute po natin doon sa equation ng resilience, okay? And then you will find po the yield strength, okay?
Baka kaya siya inagano.
Everybody has joined the whiteboard.
Naglipat daw ng 125 million ang office ng president.
Kaya hindi pumayag na kaya pumayag na vice president yun.
Okay, so I have seen yung solution po nung iba. Okay, so it was Aldrich. Sorry po ba nakita mo dito? Yung answer, so it was Aldrich. Last year, Emmanuel.
Ay, 5:30
And,
to 9:30 po ang
sino ba itong isa ito? Christian. We have also di makulangan.
Baka si SLCT San Tomas, meron na ilalamig ang inyong kupi, wala pang maglagay. Ang isagin pa kayo, alas 4 yung midnight.
Okay, so Justin Daniel, okay, who have yung answers, okay? So tama po yung answers nila, okay? So the value of your sigma Y is equal to 400 megapascal, okay? So hindi po lahat ng given po dito ay need po natin to solve for the requirement, okay? So titingnan lang po natin, sasalain lang po natin yung mga given po sa problem, okay? Yung iba po, hindi kailangan, dinalagay lang po saan para po lituhin tayo sa pagsusolve po natin. Okay? So, that is how you solve for the resilience of the material. Okay, so this is another property, we call it the hardness, okay? So when you say hardness naman, that's the hardenability of the material. Gaano po ba katigas yung ating material, okay? So when we say hardness, we define it simply as the resistance to permanently indenting the surface, okay? So ang ginagawa po natin dyan na hardness test, we have here, halimbawa po, ito po yung test natin, okay? Ito po yung material na ito-test natin as to hardness, okay? So, we have here po, this is called your indenter, okay? Yung indenter po natin, parang ipipress po natin, we apply here ang force po, okay? On the indenter, para po yung indenter natin, i-ano po natin, i-push po natin to this material being tested. So, ito yung atin na indenter, tapos you have yung force, i-ano po natin siya, okay? Ipupush po natin siya to this material. So, therefore, this will create an indentation, okay? So, magkakaroon po ng indentation on the material, okay? So, yung indentation po na yan po yung mini-measure natin, okay? So, paglaki po ng indentation dyan, halimbawa po ito yung same ball lang po yung ginamit natin, but yung material created this big, okay? Ganun po kalaki yung indentation niya, samantala yung isang material, ganito lang kaliit, okay? We say na yung may mas maliit na indentation, ibig sabihin, mas mataas yung hardness number niya as compared doon sa may malaking indentation. Okay? Considering the same force, okay? The same indenter po yung ginamit natin, but then different materials lang, okay? Paglaki ng indentation, ibig sabihin, mas soft yung material, okay? So, yun po yung palatandaan doon, okay? Ganun po ginagawa yung ating hardness test, okay? So, we determine yung diameter po nung indentation na na-create with this indenter, okay? And here po sa baba po are different materials of increasing hardness, okay? So mapapansin po natin the softest are mostly plastic, okay? At yung pinakamataas po na hardness is the diamond, okay? Kaya po yung pong ilan sa atin na mga hardness tester, yung ginagamit po natin na indenter is made up of diamond, okay? Kasi siya po yung may pinakamataas na hardness. Ang atin po ditong requirement, dapat po yung indenter, okay, ito po indenter natin na gagamitin, it should be higher po, okay, mas, yung hardness po niya, mas mataas kumpara dito sa sample material na kukunan po natin ng hardness number. Ito po yung pinag-test natin. Ito po yung sample. Ano ba yung hardness ng material na ito? Okay? So, dapat yung indenter po natin na gagamitin, okay, mas mataas yung hardness na as compared to this sample. Otherwise, pag mas matigas po ito kumpara doon sa indenter, okay, alin po ang masisira? It is the indenter and not the sample. So, mali po yung magiging test po natin na gagawin. Okay? So, basically, ganun lang po ang ginagawa onto hardness test. Okay? So, these are different hardness testing techniques.
Let's say they will
Yan.
benchmark it.
So, these are the different hardness testing techniques. So, one is the Brinell test. The second one is the Vickers test. 3 is Snoop. Okay? And then 4 is yung Rockwell. Okay? So, lahat po yan, these are for the hardness. Okay? Determine the hardness of the material. Okay? So, different techniques lang po. Pero, iisa po yung kinukuha niya. It is the hardness number. Okay? Yan. So, ano lang po ang pinakaiba ng lahat ng mga techniques po na iyan. So, same lang po iyan. Ganun pa rin po. You have yung plate to be tested. Ito po yung sample material na kukunan natin ng hardness. Ang gagawin lang, lalagyan lang po again ng indenter with an unknown amount of force. Okay, so you apply here an amount of force para po mag-create ng indentation. Okay? So, for the indenter, dun po nagbabago-bago yung mga techniques po na iyon. Okay? So, kapag Brinell po, ang ginagamit po natin is yung steel ball. Okay? So, this is a steel ball o kaya naman po made up of tungsten carbide. 10 millimeters in diameter. So, ganito po yung indenter natin. Yan po yung ipipress natin dito sa sample to create an indentation. Okay? Ito naman pong Vickers test will make use of a diamond pyramid, just like this one po. So, yung tip po niyan is made up of a diamond. Okay? So, yung pong tip na yun po yung mag-create ng indentation on the sample. Okay? Same thing po with yung loop, diamond pyramid din po. So, sa dulo po nito would be a diamond. Although, diamond po siya, sasabihin natin, napakamahal nun, baka nakawin or di napakamahal po ng atin na equipment. Okay? So, ang diamond naman pong ginagamit dyan ay napakaliit. Okay? Na almost hindi mo po ma-observe na siya ay diamond. Okay? Just to create the indentation. Okay? And then last one po, for Rockwell, you will use a diamond cone. Okay, so instead of po of a pyramid, cone naman po ang ginamit. Okay, at yung diamond tip, yun po ulit ang mag-create ng indentation. Another one is kapag Rockwell, gumagamit din po siya nung steel ball. Okay, steel ball po to create the indentation. So, this two po, yan yung nag-create ng indentation on the membrane. And how do you obtain po the hardness value? Okay, so it will simply make use of this equation. These are the formulas for the hardness number. Okay, HB, this is the Brinell hardness. Okay, ito naman Vickers hardness. Ito naman po yung Nook. Okay, dito po minsan HR ang nakalagay. This is the Rockwell number. Okay, yan, Rockwell hardness number. Meron pang ibang books aside sa halip na HB, ang nilalagay is BHN or the Brinell hardness number. Okay? So, yung pong value ng hardness, okay, o yung hardness number po, nakukuha using this equation. So, okay, katulad po nito, 2P over pi d quantity d minus d square root of d squared minus d squared. So, titingnan lang po natin, alin ba yung minimin doon? Yung P doon would be the load applied. Okay? At alin po yung big letter D? It would be the diameter of your indentor. Okay? At yung small d naman po would be the diameter nung indentation po na na-create. Okay? Kumaga po dito sa material na to, kung ito po yung ating material na tinetest, nakita mo ay nagkaroon doon ng indentation, nagkaroon ng lubog doon. Okay? So, ay may measure natin, what would be the diameter po niyan. Okay? And that would be the measure of your indentation. Okay? So, doon po, ito po ang fina-follow natin na mga equations to determine the hardness number. Okay? But do not expect po, alimbawa, iisa naman siyang material. Okay? Iisang material ang tinetest natin. So, tinest natin siya using the Brinell, tinest natin siya using the Vickers test. Okay? Maari po, okay, or hindi po, yung pong value ng HB at saka HV, okay, magkaiba po yung value. Okay? Kasi po, hindi po natin pwedeng i-compare ang dalawang material na magkaiba ang technique na ginamit. Okay? Halimbawa, nakita mo po doon, yung isang material is 300 HB. Yung isa naman is 400 HV. Yan. So, hindi po natin siya pwedeng pagkumparahin. Hindi po sasabihin natin na, ay, mas mataas ang hardness number nito kasi 400 siya over 300. Okay? Hindi po natin siya mapapag-compare kasi magkaiba po yung testing technique na ginamit natin. This one is using the Brinell and this one is using the Vickers. So, hindi po natin siya makakompare. Makakakompare lang po tayo ng hardness number kung iisa pong technique yung ginamit. Halimbawa po, 300 HB, yung isa ay 200 HB. Yan, pwede po natin siya makompare. We say, yung hardness number po na 300, mas mataas po para din kasi parehas na Brinell test po yung ginamit po natin. Maliwanag po ba tayo doon? Naintindihan po ba? Hello?
Mapupundohan siya.
Po, ma'am.
Okay na? Okay, so pare-parehas lang po yung principle na ina-apply. Okay? Again, ano lang po pinagkaiba ng mga hardness testing technique na yan? It is the indenter na ginamit. Okay? Yun po indenter na ginamit, yung force na in-apply, at yung pong formula. Okay? Na nangyari. Okay? Or in-apply po natin. Okay? Ayan. So, that would be hardness as another mechanical property. Okay, so here naman po is the through stress strain diagram. Okay, kahapon po I have discussed to you the stress strain diagram. Nari po yun, di ba? Yung if you have there yung ductile natin, okay, meron pa ganon at meron po ganito. Ito din po yun, okay? This is yung point M po or yung point D po natin as the ultimate strength. We have here yung point E at yan po yung E prime, okay? This is theoretical. And this one po would be the actual. Okay? So, ito din po yun. Yung pong true, yun po yung actual. At yung engineering stress strain po, yun po yung theoretical. Okay? So, pertaining to the ultimate strength po, yung isa pababa, yung isa po ay pataas. Okay? So, the true stress strain diagram would be the actual. Okay? Yung actual rupture strength po, yun po yung dulo. Okay? Kapag po sinabi natin engineering stress strain diagram, yun po yung theoretical wherein nasa pinakamataas pong point yung point D which is the ultimate strength. Okay? So, sana balikan na lang po natin yung explanation ko po doon kahapon. Okay? So, bakit po mas mataas yung value ng stress doon sa actual kumpara dito sa engineering or yung true versus that of the engineering. Again, ang true po would be yung actual at yung engineering po would be yung theoretical. Okay? Again, there are two reasons on why this is higher than the ultimate strength. Okay? So, it comes along with the force and yung area po. Okay? May question po ba tayo doon? Hello?
Wala naman po.
Okay. So, ito pong nasa slide 26, okay? So, nadidin po yun sa sunod na module ko po na i-discuss. So, shift muna po ako nung sunod na module.
Pagdating sa mga transcendent ang reciprocal ay ang secant, cosecant at cosecant ng sine, cosine at tangent. Pero pag sinabi ng inverse, so meron ulitan na inverse ang bawat isa. Pag ang given ay
Okay, so I given you this as your assignment. Difference between ductile and brittle material.
Yes po.
Okay, so bago ko po ito i-present, okay? Okay, so i-ano po muna natin, okay? So I want to have po ay ano ba yung na-research po natin, okay? So I would like to call on names, okay? And then tell me what would be the difference between a ductile and a brittle material, okay? Anyone? Volunteer muna po. Can you volunteer? Ano po yung difference pag sinabi po natin na ductile at brittle? So, sa pag-uusap po natin last time, okay, sinabi ko lang are samples of yung food under ductile and brittle material, okay? So, let us have first po muna Althea. Okay?
Based on my research po, ma'am, ductile materials po ay nagsashow ng deformation while ang brittle materials po ay
Again, nagputol-putol ka ining.
based on my research po, ang ductile materials po ay nagsashow ng deformation while ang brittle materials po ay hindi.
Okay, correct. So there is deformation, appreciable deformation for ductile material. Sa atin po na brittle material ay wala. Okay? And then we have Andrian. Andrian?
Hello po, ma'am.
Yes po.
Sa ductile po, ma'am, ano po siya, nag-stretch po siya. Pero yung brittle po, mabilis po siya mag-break po.
Okay, so that is correct. Okay, so that is in terms of the failure. Okay, Alma.
Same lang din po halos. Since ang ductile naman po is nga po na-stretch po, unlike po sa brittle po nagbe-break po when stretch po.
Okay, correct. And then last one, para kang ano pa is, yes, Reniel.
Ano ang value ng arc sine ng 1?
Reniel.
Conductive po ano po, affected po siya by temperature while po yung pong brittleness po ay affected by pressure po.
Okay, tama. Okay, and then we have Emmanuel.
Good afternoon po, ma'am. Rinig po ba?
Yes po. Yes po, yes.
Yung na-research ko naman po ay same lang din sa kanila. And sa ano na lang po, sa mga example na lang po ng ductile at brittle po. Sa ductile po, ang example po ay mga mga glass, ceramic, mga ganun po. Then pag naman po sa brittle, mga metal, ganun po.
Okay, correct. And then another one, Aldrich.
And you will get 90 degrees. Or
Hello?
pi over
Sino nga ba yung nag-raise kanina ng hand pass?
2 degrees ang quality is 90.
Yes, Daniel.
Ma'am, ano po, ang ductile po ay low strain po, tapos ang brittle po high strain po.
Okay, correct. And si Aldrich pa rin pala kanina nag-raise din ng hand.
Francis S. Rian.
Ang bali po sa na-research ko po ay brittle deformation. Brittle po yung rock fractures po ay yun po, once in strength is surpassed. While ductile po, where rock size and shape changes without fracturing po.
So parang
Okay, correct. Okay. So, yan po mga yan na binanggit nyo ngayon. Okay. So, isum up po natin with, ito po nandito sa atin na module. Okay. So, let me show it again.
although may isa pang angle ng arc sine ng 1/2, yung pinaka 30 degrees sa second quadrant.
Okay.
180 minus 30, 150.
Okay, so yan po yung comparison. Okay, so the table shows the comparison between the ductile and the brittle materials. Okay, let us see. Ano po yung una? Okay, so nakalagay po dito, for ductile, we have low and medium carbon content. Okay, whereas if you have their high carbon content, it would be considered a brittle material. Okay, for ductile material, it is basically soft and basically hard for brittle material. Okay, so self-explanatory naman po itong soft at being hard na material. Okay, next is high resistance to deformation and low resistance to deformation. So katulad po ng nabanggit nila kanina, okay, ng mga tinawag ko po. Okay, so appreciable deformation is observed in a ductile material. Okay, yung elongation po, that is a form of a deformation. Okay, so mas nagde-deform po yung ating ductile material as compared to that of a brittle. Next, fails by yielding or netting, whereas brittle fails by fracture. So may nakabanggit din po dito kanina. Okay, so yung isa po, mahaba muna, nag-i-stretch muna, nagkakaroon po ng yielding. And then necking po, lumiliit yung cross-section habang humahaba hanggang sa maputol po siya. Okay, so yan po yung magiging result or yun po yung magiging sanhi kung bakit siya naputol. Okay? It is by yielding or netting. That is why failure occurs. Okay? Whereas kapag brittle naman po, you would never see that na nagkakaroon po ng elongation or nai-stretch po or nagkakaroon ng netting. Ano po ang nakikita natin sa kanya? Nagkakaroon po siya ng crack and then eventually po ay sira na po kaagad. Okay? Mapuputol na po kaagad. So, yun po yung fails by fracture. Okay? Next, has a defined yield point and no defined yield point. Okay? So, yan po yung diniscuss ko kahapon na stress-strain diagram. Okay? Di po ba kahapon, may stress-strain diagram tayo for ductile at saka stress-strain diagram for brittle. Sa ductile po, we have there several points from A hanggang E and E prime. Okay? A, B, C, D, E, and E prime. Yun po ang present yun sa ductile. So, I hope everybody alam po yung ibig sabihin ng cada letter. Anong point yung nire-represent po nila. And then, pagdating naman po sa brittle material, ano lang po yung mga present na letters? O sino pong nakinig kahapon? Ano yung mga present na letters lang? Okay, yes, Janelle, Ines.
Letters A, D, and E po. Wala pong point B and C.
Okay, so A, D, and E lang. Ang nawawala po would be yung B and C. Okay, so ano po yung B and C? Elastic and the yield point. Okay, kaya po sabi dito, the ductile has a defined yield point. So may yield point po siya. Not unlike that of a brittle na wala nga po yung points B and C. C in particular is the yield point. Okay, and then the last comparison po, more resistant to impact loading, and then the other one is less resistant to impact loading. Okay? Ano po yung ibig sabihin ng impact loading na? Okay? So, meron po tayong tinatawag na static load. Okay? At ang isa po ay yung impact load. Okay? Alin po yung static load? Ang static load po, halimbawa po, ay tap the table once. Okay? So, tinap ko po yung table isang beses. So, the amount of force na ginamit ko para itap yung atin na table, okay, yan po yung tinatawag natin na static load. Okay? So, isang beses ko lang po siya in-apply and at a definite amount po yung force. Okay? The second one naman po is an impact loading. Okay? Alin po naman yung impact loading? So, kabalik na lang po noon. Halimbawa po, ilang beses kong tinap yung ating table. Okay? Ilang beses kong tinap. So, ibig sabihin, ang application po ng load, madaming beses. Okay? And in terms of the amount po, pwedeng pare-parehas yung amount ng pagkakatap ko at pwede rin naman po na nagva-vary. Okay? So, yun po yung impact loading ko na sinasabi. Okay? So, example po niyan is jackhammer. Okay? Do you know what a jackhammer is? Hello? Alam niyo po ba yun? Hello? Nakakita na na po kayo noon. Anong ginagawa doon? Paano mo siya i-describe, Aldrich?
Yung po ba yung sa mga kalsada po pag parang pag nagliliba po ng mga bato?
Oo, tama. Anong masasabi natin with the applied load po doon? May kwento nga po ng kaunti.
Parang nagba-vibrate po siya, yung lumayanig po yung parang.
Okay, so tama po yung sinabi niya. Ginagamit po iyon para masangin po yung atin na concrete. Okay, so mga karsada po natin. So binabasa po niya. Okay, so you look at the load na ina-apply po sa kanya. So paulit-ulit po. Okay, para mabasag natin yung concrete. And the amount of load na ina-apply natin, pwede po yung constant. Okay, pwedeng pare-parehas ng 10 Newton, pero pwede rin naman na i-iba. Okay, depende sa thickness mo concrete na atin po babasagin. Okay? Of course, pag po mas hard po yung concrete, okay, di po mas madami or mas malaking amount ng load po ang need natin para po siya ay mabasag. Okay? So, yun po yung tinatawag natin as the impact loading, which is very different from that of a static load. Okay? So when we say this kind of loadings, okay, this impact loading, that is more resistant po doon yung atin na ductile material. Kung yun yung load na gagamitin natin, mas kaya siyang i-resist noong ductile material as compared to that of a brittle. Okay? Pag in-applyan mo siya nito, hindi agad din siya magfa-fracture. Okay? Hindi rin agad siya mag-fail. Okay? So, it will have a deformation muna po bago yung failure. Pero po dito, kapag po siya ay brittle, baka hindi natin po siya pwedeng applyan itong impact load. Even static nga po, agad nag-failure na siya. So, how much more if we use an impact loading? Okay? So, yan po yung comparison natin between a ductile and the brittle material. Okay? And I want to elaborate more po on the first comparison. Okay? Balikan ko po yung kanina. Hindi ko po yung in-explain kasi the succeeding slides po natin will pertain to this comparison. Okay? So again, ang una po comparison natin, low or medium carbon content for ductile and high carbon content for brittle. Okay? So meron po tayong tinatawag na AISI and SAE designations for steel. Okay? Again, I think this is my assignment to you. Okay? So, ano po ba yung tinatawag natin na AISI and SAE designations for steel? When you say AISI, it is an acronym which stands for, ano po ibig sabihin no? Acronym po na yun? Hello, anyone? Anyone po? Ano po ang ibig sabihin noong acronym na AISI? Parang assignment po yun. Yes po. Iba naman pong, yes po, yes. Mr. Barcelos, Aldrich.
Ako po ba, ma'am?
Wala namang iba nag-raise kundi kay ni Janela.
Ano po? American Iron and Steel Institute po.
Okay, correct. That would be the American Iron and Steel Institute. Okay, what about the other one? SAE. What about the SAE? Okay. Justin? Okay, correct. Okay, that is Society of Automotive Engineers. Okay, so yun po yung ibig sabihin ng AISI and SAE. Okay, so American Iron and Steel Institute for the AISI, and for the SAE, that is Society of Automotive Engineers. Okay, so these two, these are industries which are engaged in designating steel po. Okay? So, yan po yung trabaho nila. When we say designating steel, okay, you are to name the steel. Okay? So, in-name po natin siya according to its composition. Okay? Ano ba ang meron yung steel na iyon? Okay? When we say steel po, okay, it is simply equal to iron added with alloying elements. Okay? So when we say alloying elements, it can be one or it can be many. Okay? Combination of elements. But mainly composed po siya ng iron. Maximum percentage na around 90% and above, that is made up of iron. Okay? That is why po, sa Tagalog po, we both call them bakal. Okay? Kasi nga po, mainly iron po siya. Okay? So, ito lang po is in pure form yung iron. Pag sinabi po natin steel, hindi na po siya pure kasi dinagdagan na po natin siya ng alloying elements. Okay? So these alloying elements, ang function po niya is to enhance the property of iron, making it applicable to a certain application. Halimbawa po, nagkaroon tayo ng stainless steel variety. Why? It is because needed siya doon sa mga food applications. Okay? So, hindi kailangan kalawangin. Otherwise, it would be poisonous. Okay? Kaya anong nangyari? You add alloying element to the iron to come up with a stainless steel variety. So, in particular, you add chromium. Okay, para po magkaroon tayo ng stainless steel. So, iba-iba pong alloying elements ang dinadagdag natin doon sa iron. At iba-ibang element na idinadagdag mo would have a different effect din po doon sa atin na iron. Okay, kumbaga, depende sa aspect na gusto mo pong i-improve. Okay? So, yun po yung sinasabi dito na designations for steel. Okay, again, designation is that you are to name the steel. Okay, ano bang composition meron siya? Okay, so both AISI and SAE is represented by 4-digit numbers. Halimbawa po, may nakita po tayo doon, AISI 2320. Yan. Okay? So, yun po yung 4 na digit na number. Okay? And kada digit po na yan, meron pong ibig sabihin. Right? So, ganun din po. Halimbawa, SAE 2320. So, ganun din po ang ibig sabihin nung 4 na yun. Magkaiba lang po yung industry na nagpangalan sa kanya. Okay? So, ano po yung unang number? Okay? Yung unang number po, or unang digit, it refers to the type of steel. Okay? When you say to the type of steel, o paano ko po nasabi na yun yung type ng steel? Okay? Ang type po ng steel, sabi nga natin, major alloying element po yung type ng steel. Kasi siya po ay mainly composed of iron. Okay? So, kung dito po sa alloying elements, kung alin po yung may pinakamataas na percentage sa mga alloying elements, yun po yung major alloying element at yun din po yung magiging type ng steel. Halimbawa po, nakita mo dito, may nickel, may chromium, meron ditong carbon. Okay? So, tingnan mo yung kanyang percentages. Okay? Kung alin yung may pinakamalaki doon, yun yung pangalan ng steel natin. At yun din ang major alloying element. Okay? So, yun po yung nauuna. Okay? So, dito po, ang pwede po nating number dito will be from 1 hanggang 9. Okay? So, yung mga possible numbers po dyan, 1 hanggang 9. At kada isang number po doon, may ibig sabihin or merong corresponding type of steel. Halimbawa po ito, ari po ay 2320. So, 2 po yung unang digit. Ano po kaya yung ibig sabihin kung 2 yung unang digit? What type of steel po ito? Hello, what type of steel po iyon? Sino po diyan nag-review? Sino po naghanap ng assignment natin? Okay, tama. So, tama si Althea. It would be a nickel steel. Okay? So, ibig sabihin dito sa alloying elements, nickel yung may pinakamadaming composition. Kaya tinawag po siya na nickel steel. Okay? So, iyan po yun. So, sabi ko nga po kanina, ang possible po natin doon ay 1 hanggang 9. Okay? So, kapag 1 po yan, ibig sabihin, it is a carbon steel. Okay? Nakita po natin 1, tapos may 4 pa na digit na number. Kapag 2 po, it would be a nickel steel. Okay? Pag 3 po, nickel chromium steel. Pag 4, it is molybdenum. 5 is chromium. 6 is thank you. 6 is chromium vanadium steel. 7 is tungsten. 8 is, ito po yung tinatawag natin na triple alloy steel. Okay, triple alloy. Why? It's a combination of nickel, chromium, and vanadium. And then kapag po 9, nakita natin that's silicon manganese steel. Okay? So, dapat po alam po natin. Okay? So, pagkita pa lang po natin doon sa unang number, we can identify na po the type of steel. Okay? So, you memorize po this designation, yung mga number po na iyon. Okay? And then we go to the second digit. Okay? Ano naman po yung second digit? The second digit will pertain to the percentage of major alloying element. So this is the approximate percentage. Katulad po nito, 3. Okay? So sabi nga po natin, ang major alloying element would be yung pinaka mataas dito sa mga alloying elements na dinagdag po natin. Okay? And that would refer to the type of steel. So kung ano po yung type ng steel, yun din po yung major alloying element po. Okay? Kaya halimbawa po yung kasunod na number would be the percentage kung ano po ito. Okay, katulad po nito. 2 is a nickel steel. Okay, so ano po yung 3? This contains approximately 3% of nickel. Okay, so this AISI 2320 is a nickel steel having approximately 3% of nickel. Okay, so ano po yung percentage kung ano po yung nandun sa unahan or yung type ng steel na ito. Okay, so if you look at the percentage, so 3% lang po. So kung mapapansin nyo po, napakaliit lang po or traces lang po yung percentage po na iyon. Kasi nga po, it is mainly composed of iron. Okay, majority po niyan, okay, is composed of iron. These are simply traces added para ma-improve po natin yung property. Okay? And then the last two digits po, okay, that refers to the points of carbon. Okay? So, katulad po nito, this has 20 points of carbon. Okay? So, it contains 20 points of carbon. So, different po yung points with the percentage. Okay? That is 20 points of carbon. This is, if you wish to convert that into percentage, that is 0.20% carbon. Okay? So, magkaiba po yun. Nakuha po ba? Okay? So, ito po, yung pangalawang digit po, that's the percentage already. But then the next two numbers po, that will refer to the points. So, kung i-convert po natin, lalagyan po natin ng points sa unahan. Okay? So, iyan po yung kanyang composition. So, when we say AISI 2320, it's a nickel steel. Okay? Nickel steel with 3% nickel and 0.20% carbon. Okay? So, ganun po dapat natin siya mai-interpret. Okay? So, dapat po maalam tayo bumasa. And if we have their SAE 2320, yun din po yung ibig sabihin. Okay? Parehas lang po silang dalawa. Nakuha po ba yun? Hello?
Yes po, ma'am.
And then, ano po yung pinakamahalaga dyan? Ang pamahalaga po dyan is yung points ng carbon. Okay? From the points of carbon po, dun po natin madidetermine whether the material is ductile or brittle. Di po ba sa definition natin kanina, sabi po natin, doon sa ductile, it is low or medium carbon content. Kapag brittle po, high carbon content. So, pagtaas po ng carbon content, okay, the more it will become brittle. Okay? So, ang titingnan po natin yung dalawang kulay number. Okay? If it is above 50, okay, above 50 points of carbon, yan. Yan po ang sasabihin natin na siya po ay brittle. Okay, so kung i-interpret po natin na rin 2320, is it a ductile or a brittle material? Hello, ductile or brittle po yung 2320.
Brittle po.
Correct, 2320, this is a ductile material. Okay, ductile. Kasi sabi ko, above 50, yun po yung carbon. Okay, above 50, yun po yung carbon. Okay, so yun po yung ating magiging basehan po. Okay? Titingnan po natin yung dalawang huling number. If that exceeds 50, then we say it's brittle. But then 50 and below, it would be ductile material. Okay? So yun po ang tatandaan. Now, ano po yung difference between these two? The AISI and the SAE. Okay? Parehas po yung description ng apat na digit na number. Ang pinagkaiba lang po, pag AISI, may dinadagdag po tayo na letter. Okay? It can be a single letter or it can be a combination of letters. Okay? Or group of letters. Added before the number or after the number. Pwede po nakikita natin minsan, AISI 23, C2320. So, nandun po yung letter. O kaya naman po ay 2320 WQT. Okay? So, it is only AISI who has yung mga letters po na idinadagdag na yan. So, sabi ko nga po, pwedeng nasa unahan ng number, pwedeng nasa hulihan ng number. It can be a single letter o kaya ay combination of letters, okay? Or group of letters, okay? So, ayan pong AISI lang yung may ganyan. The SAE, wala po, okay? So, these letters po, that refers to the processes that yung in-undergo ng material. Okay? So, in specifically, kapag po WQT, we call this the water quenched tempered. Okay? Ibig sabihin po niyan, hinit po natin yung metal, okay? Hinit po natin yung material, and then afterwards, nilublob po natin doon sa water, okay? Right away, okay? So, yun po yung water quenched tempered. That is to increase the strength of the material, okay? So, yan po yung difference lang ng dalawa, but then overall, parehas na mo po siyang babasahin, okay? Now, so given this, okay, let us now identify whether this material is ductile or brittle and it's also composition. Okay, halimbawa po, AISIC 1095. Okay, how do you interpret pong material na ito? Anyone? Hello? O para po yung kanina, yung sinabi ko po, yung sample po natin. AISI 2320. Okay? So this one is a nickel steel. Okay? So this is a nickel steel. Containing approximately 3% nickel and 0.20% carbon. And overall, you can categorize this simply as a ductile material. Okay? Okay naman po. Yung number 1. Van. Okay? Ito nga po, van. Hello, pakinig po ako. It is a brittle material. But can you please identify yung composition ng C1095? Katulad po nitong ginawa ko dito. This is a nickel steel with 3% nickel and 0.20% carbon. O, van. Yung C1095. O anyone po. Tama po si Van dito. This is a brittle material. Okay? Yes, Justin. Tama po yung kay Justin. It's a plain carbon with 0.95, okay, percent ng carbon. Okay? So, tama po yun. And categorized as a ductile material. Okay? Let us have number 2. Hello? Number 2 naman. Yes, Miss Janela?
Sa number 2 po ay brittle and it is a silicon manganese steel with 8 points of carbon.
Parang mali, ineg. Parang mali. Okay? Yung pangalawa po would be the percentage kung anong type ng steel. Okay? So, tama po. Silicon,
Ayun po pala,
manganese
8
steel,
points of
8
silicon manganese.
with 8%. Okay? Silicon, manganese. And, gaanong carbon? Hello?
0.50 po.
0.50% po.
Okay, so 0.50%. Okay, so ari po would be silicon, manganese, okay, with 8% nito pong silicon, manganese, and 0.50% carbon. Ductile or brittle?
Brittle po.
Hindi. It would be a ductile material. Di ba sabi ko kanina, it should be above, okay, 50 points. Okay? Pag 50 po, that is still considered to be a ductile material. Okay? Naintindihan po ha? Yun po yung cut-off, yung 50. But then above 50, yun na po yung brittle. Okay? Oh, what about ring number 6 po? Another one. Number 6. Oh, iba naman. Sino kayang pwede din eh? Miss Aliana. Miss Aliana? Are you... Oh, ano po yung 6? Ano po ibig sabihin ng 6? Dapat po alam lang natin yung mga nasa unahan na yun. Okay.
Chromium po. Chromium vanadium po.
Tapos, ano pa kasunod?
Tapos po, ito po ay 1% po na carbon.
Ano po yung pangalawa? Di ba, tulad mo po dito sa mga aking sinulat dito. Ano po yung pangalawang letter? Ano po yung pangalawang number? Ano pong ibig sabihin niya?
10% po na chromium vanadium din po.
Ilang percent?
1% po pala.
1%. Okay?
Sabi po na mali.
Tapos, anong kasunod? Ano pang kasunod?
Tapos po, 0.52% po.
Ng ano? .52% ng?
Ductile po.
0.52% ng ano?
Chromium vanadium po.
Hindi. Nag-hook mo tayo na. Ano yung dalawang huli?
Carbon po.
Carbon. Okay? So, wag po tayo malito. Yung dalawang huling number, yun ang carbon. Okay? Yung pangalawang number, yun yung kung anong type ng steel, yun yung percentage na. Okay? So, wag po natin maglahukin. Okay? So, ang gagawin nyo po, pag na-upload ko po itong aking module na ito, itry nyo po 12 ito, okay? Itry nyo po yung 12 o paano mo i-interpret, okay? Kailangan po maalam kayo mag-interpret niyan. O halimbawa, 1040, okay? So this is a plain carbon steel with 0.40% carbon, and that is a ductile material. Okay? So yun lang po ang atin dapat na i-interpret sa kanya. Kapag lang po AIS, ayan, meron pong letter C. So, dapat idagdag natin. Ano ba yung ibig sabihin ng letter C? O, nakita ko po nga, meron po doong WQT. So, ano ibig sabihin nun? It's a water. Taglat lang. Okay, so if you have there yung C, WQT, it would mean water, quench, and tempered. Okay, so that's W, Q, and T. Okay, water, quench, and tempered. Yun yung sinabi ko kanina that you will be heating the material and then right after po, ilulublog po natin onto water. Okay, o ito naman po, katulad po nila. Meron po OQT. Ano po ibig sabihin ng OQT? Any guess po? What is OQT? Hello?
Oxygen po.
Hindi ka po kasi.
Oxygen. Tapos, ano pa?
Quench and temperature.
Quench and tempered. So, tama po yung quench and tempered. Pero hindi po yung oxygen. Thank you, ma'am. Pero hindi po yung oxygen. Kundi, yun po ay oil. Okay, yan. Oil po. So, you will have a different medium. Kasi hindi na po water, kundi oil na po. Okay? Pero pag halimbawa po, nakita po natin na DWQT or SWQT. Ano po kayang ibig sabihin? So, yung QT, yun po ulit, quench and tempered. So, ano po yung DW at SW? Ano yung DW at ano yung SW? Guess uli. Hello? Ikaw kaya. Sino bang matawag dito? Kent Irvin Maramot. Ano kaya yung DW at SW? Any idea po? Kent? Hello? Naririnig po? Kent Irvin? Wala ka ba dyan? Miss Janela, take note ha, yung mga wala. Ito si Miss Michelle. Miss Michelle. Wala din. Hello?
Try ko po, ma'am.
Sige,
Distilled water po.
Okay, distilled water. What about SW?
Spring water po.
Ano?
Salt water po, ma'am.
Salt water. Okay. So you have there distilled water and salt water or seawater for SW. Okay? So yun po yung guess po nila for DWQT at saka SWQT, which is of course not correct. Okay? So hindi po yun tama. Okay? So wag niyo pong gagawin na distilled water or seawater, quench and tempered. Okay? Mali po yun. Okay? Yung DW po means this would mean double water, quench and tempered. Okay? At yung SW po, yun po ay single water, quench and tempered. Okay? So single at saka po double lang. Okay? So, wag po kung ano-ano ang ating ilalagay. Distilled water, seawater, salt water. Yan po yung mga common mistake po. Okay? So, ano po ang dapat yung gawin dyan? Okay? So, doblehin po natin yung sipag. Okay? So, hanapin po natin ano ba yung mga letters or group of letters na dinadagdag po natin on the AISI designation to mean po yung process na in-undergo po nung material. Okay? Naintindihan po ba? Hello?
Yes po.
Yun po mga hindi po nasagot dyan. Baka po mamaya maisipan ko i-kick out ko na po kayo din sa sa Meet. Para kayo po ay sumagot kahit po hindi alam. Okay lang po yun. Basta na-email at alam ko po na naandyan kayo sa atin na Meet. Okay? So, pwede naman po, ay, hindi ko po alam ma'am or ganito. Pero, yung hindi po tayo umimik, ay, it's a manifestation na wala po talaga kayo dyan during our meet. Okay? So, I would ask you, I would, of course, say to, sa atin na coordinator to mark you as absent during our meet. Kung ganyan din lang po na hindi po kayo magsasalita or talaga naman po na wala po kayo dyan. Okay? Sana po yung nakakaintindihan tayo. Hindi po si Miss Janela, si Aldrich, at yung ilan pa po dito. So, bilang ko po dito kung sino lang po yung nagsasagot, okay? Yung nagre-respond doon po sa akin na mga tinatanong. Yung iba, kahit tinatawag na, hindi pa rin po nagsasalita. Siguro nga po wala kayo dyan sa atin na meet po na yan, okay? Kaya pagka po ganoon, so wag po magtatampo kung kayo po ay aalsin ko na dito sa atin na meet, okay? I-remove ko na po kayo from the call. Okay, so let me continue. So again, that would be your assignment po ha. Ay katulad po nito, alamin po natin ano ba ang ibig sabihin ng bawat, okay, designation po na iyan. You should be able to interpret, okay, kung ano yung bawat number na naka-indicate po dito. Okay, so saan po natin siya gagamitin? Okay, so we have what we call po the design or the allowable stresses. Okay, so when we say the design or the allowable stresses, okay, dapat po alam natin if the material is ductile or brittle. Okay, so ang isa nga po nating palatandaan para malaman kung ductile or brittle siya is on the number of or the points of carbon. So yung dalawang huling number sa designation. Okay, because you will be using that to determine your design stress. When we say design stress, it's the allowable stress, and another term for it is the working stress. Okay, so pare-parehas lang po yan. Okay, so when we design the material, okay, we want to know the working stress. Okay, and you look at the equation for the working stress or the design stress. We have the stress symbol, sigma, and then subscript D. Okay, so sigma D, it can either be sigma U over factor of safety or sigma Y over factor of safety. So yun po yung ating dalawa equation. Sigma U over Fs, or the design stress would be sigma Y divided by factor of safety. Okay? So ito po, the design stress is based on the ultimate strength. Okay? At ito naman po, the design stress is based on the yield strength. Okay? Ito po isang to. Ano pong sigma U? Ito po yung point D natin sa stress strain diagram. Okay? Ari naman pong sigma Y, ari po yung point C. Okay? So, saan po natin gagamitin? Paano ko po malalaman kung ito po ba yung gagamitin ko as the design stress or ito po? Okay? So, depende po yan sa requirement ng problem. So, sinabi po sa problem that base design on the ultimate strength, so you have to use this equation. Okay? Pero pag sinabi po base design on the yield, so ito po iyon. Okay? So, paano naman po ma'am kung hindi po banggitin ang basis ng design? So, doon na po papasok yung ating type ng material. Okay? Di ba po? Meron tayong ductile at saka po meron tayong brittle. Okay? Kapag ductile po, ang basehan po ng ating design stress would be the yield. Okay? At kapag po naman brittle, it would be the ultimate strength. Okay? So, ibig sabihin po, kapag ductile material po, ari po yung gagamitin nating equation. Sigma Y over Fs. At kung siya naman po ay brittle, then you will be using this equation. Sigma U over the factor of safety. Naintindihan po ba yon? Nakuha? Hello?
Yes po.
Okay, good.
Yes po.
Okay? So, yun po yung gagamitin natin as yung sigma D. Okay? Meron din po tayong tinatawag na tau D. Okay? Tau D can be tau U over factor of safety. At ang isa pong equation, tau D is tau Y over factor of safety. Parang ito din po yun. Okay? Ari po ay para sa brittle at ari po ay para sa ductile. Ganun din po. Okay? Ductile, yield, brittle, ultimate. Okay? Yan po ang ibig sabihin. Okay? So, ayun po yung tinatawag natin as the working stress. Okay? And now, ano pong gagawin dito sa working stress po na yan? The working stress po is to be equated to what we call induced stress. Okay, ari pong design stress natin, ari po yung sigma D equal to sigma U over Fs o kaya naman po ay sigma Y divided by factor of safety. Dependent upon kung siya ay brittle o kaya po ay ductile material. Okay, so ayan po yun. But then, alin po naman yung induced stress? Ang induced stress po, these are the stresses na inaral po natin on our mechanics of deformable bodies. Alin po yon? Tensile stress. Okay? We have compressive stress. Okay? Yan. We have also shear stress. We have torsional shear stress. At ang isa po yung flexural or bending. Okay? Flexural / bending stress. Okay? So, yan po yung mga induced stresses po natin na yun. Okay? And they are to be equated. Now, so balikan lang po natin yung mga equations po natin on the induced stresses. Okay? Ari po yung action. Ang action po, ito po yung tensile at saka po compressive stress. Yan. Okay, so ang ating equation po doon, sigma is equal to force over area. Okay, kapag shear naman po, we make use of the symbol tau. It is the shear force V divided by the area. Sa torsion po, ari po yung sa mga members na umiikot. So we use tau equal to TC over J. T pertains to the torque. Okay, and J is the moment of inertia, polar moment of inertia. And flexural, this is your bending stress. Okay? Yan po ay sigma sub F equal to MC over I, where this M pertains to the maximum moment. So sana po ay naaalala pa po natin ulit yung mga equation na iyan. Okay? So ito po equations na yan po yung mga stresses na yan. Ang tawag po natin yan are the induced stresses. Okay? These are the stresses caused by the mechanical forces that you applied to the material. Okay? So, yun po yung induced stress. And what we do with these stresses, yan po ay ine-equate natin doon sa kanina po na sinabi natin na design stress. Okay? So, doon po natin siya i-equate. So, dito po, since ari po ay sigma, then i-equate po natin siya sa sigma T. Yan po yung design stress. Ari po ay tau. So, ari po ay equate natin sa tau D. O tau po ulit. So, ari po ay design stress na tau din po ang unit. Ay, ari po ay sigma. So, equate po natin siya sa sigma D. Okay, again, ano po yung equations for sigma D and tau D? Okay, yung sigma D po would be equal to what? Sigma U over factor of safety or sigma D equal to sigma Y over factor of safety. Kailan nga po ari gagamitin? Hello? Sigma U over Fs. Brittle. At ari pong sigma Y over Fs.
For ductile po.
For ductile naman po. Ang tandaan lang nyo po dun ay yung debug. Yan, debug. Ductile, yield, brittle, ultimate. Okay? So, yun po para madali nating tandaan. Okay? Ito naman pong tau, kung ang atin pong induced stress ay tau, so ang atin pong design stress would be tau din. Okay? Yung tau D would be equal to tau Y over Fs or tau D would be equal to tau U over Fs. Ulit, at tanong ko ulit, kailan po ari gagamitin? Aring unang equation, yung tau Y over Fs.
Ductile po.
Ari po, tau U over Fs.
For brittle po.
Brittle. Okay, so wag po tayo malilito dun ha. Depende po sa ductile o brittle yung material. Ang gagamitin po natin, design stress. Again, saan po tayo titingin para doon sa designation para malaman kung ductile or brittle? Yun pong dalawang huling number. Okay, dalawang huling number. If it is above 50 po, okay, above 50, yun po ay brittle. Okay? 50 and below, yun po ay ductile. Okay? So, sabi nga po natin, low and medium carbon content, yun po ang ductile. So, yun po yung mababa. Okay? High, above 50, okay? Yun po yung brittle material. Okay, so let us take the case of this sample problem. Okay, so sa sample po natin, may tinatawag po tayo na factor of safety. Di po ba sa equation natin kanina? Okay, yan, nilalagay po natin for the design stress, yung pong ilalim may Fs. Okay, sigma U over Fs or sigma Y over Fs. Yung pong Fs na yon is called the factor of safety. Okay? So, yung factor of safety po, minsan po ang tawag sa kanya, it is called a design factor. Okay? Yan. Para po yung kung sa damit, we provide allowances po. So, ganun din po dito. When we design the member, we provide allowances. Okay? So, yun po yung factor of safety. Para po, we are sure na safe po yung ating dinesign na structure or our mechanical equipment. Okay? So, the factor of safety, minsan po, FS ang ginagamit, but then there are other books na instead of FS, N po yung ginagamit. Okay? So, okay lang din po yun. Okay? So, this is the factor of safety. And often, this factor of safety is between 1.2 and 4. Okay? Kumbaga po, yun yung ideal na ginagamit natin na value. Okay? But then, meron pong iba na gumagamit pa higher than 4. Okay? Paglaki po ng factor of safety, of course po, alam po natin na mas magiging safe po yung ating design. Okay? Ang limitation lang po, bakit po nakalimit po siya sa 1.2 and 4. Ibig sabihin, po yung kalimitan na ginagamit. Okay? Kasi pag nilakihan po natin yung factor of safety, ang mangyayari po, lalaki naman yung dimension, which is, hindi na po siya papasok doon sa economical requirement. Kasi mamamahal na. Okay? Paglaki ng dimension, although it is safe, ano mangyayari? Mas mahal mo naman siyang mabibili. Yung initial cost ng material, sobrang mahal naman. Okay? Kaya dapat, yung i-incorporate po natin na design factor should be great enough para makuha po natin yung optimum value na hindi po siya mamamahal yung operating cost po niya. Okay? So, we have here po yung factor of safety, it is between 1.2 and yung 4. Okay? So, yun po yung ginamit natin, okay? Para po ma-ensure natin na safe po yung ating magiging material. Okay? So, you have here the sample problem. You calculate the diameter D to ensure that yield does not occur in 1045 carbon steel rod below. Okay? Use a factor of safety of 5. Okay? So, katulad po nung nabanggit ko kanina on the designation for the steel, okay, you can determine whether the given material is ductile or brittle. Okay? So, in this case po, you are given here 1045. Okay? So, ano po yun? Ductile po ba ito o brittle po?
Ductile po.
Okay, ductile. Okay, so again, sabi ko nga kanina, ang titignan natin po would be yung dalawang huling number. Okay, so interpret this po, this 1045, this is a plain carbon steel with approximately 0.45% carbon. Okay, and using this 0.45, it would mean a ductile material. Okay, so kung siya po ay ductile material, then the basis of design is ultimate or the yield. Hello? Hello po. Kung ari po ay ductile material, ano po yung magiging basis po ng ating design?
Yield po.
Yield
It
po.
would be the yield, correct. So you are given here the yield strength, okay, sigma y equal to 310 megapascal, and this TS po is the ultimate tensile strength, okay. Ito po yung atin na sigma U, okay. Ano po yung sigma y, ano po yung sigma U, 565 megapascal, okay. And ito po yung atin na rod, okay. You have there the diameter D. And then you have your a tensile load of 220,000 Newton applied to it. Okay? This is the original length L support. Okay? So ano po yung pinapahanap sa atin? What should be the diameter? Okay? Na magagamit natin to ensure that the yield does not occur on this particular carbon steel rod. Okay? Using a factor of safety equal to 5. Okay, so ano po yung ating gagawin? How do we determine the value of the diameter? Okay, so uunahin po natin yung design stress po natin. Ano nga po yung ating equation for the design stress? This will be based on the yield, sigma y over factor of safety. Okay, why sigma y over fs? It is because this one is a ductile
Ductile.
material. Okay, correct. Okay. So, you are given here na po yung sigma y. Same thing with the factor of safety equal to 5. Therefore, you can compute for the design stress. Nakuha po ba? Hello?
Yes po, ma'am.
Okay. And then afterwards, ano po ang gagawin natin? You are to equate this design stress doon po sa atin na induced stress. And what is the induced stress here? We apply here a tensile force. Okay? So therefore, if you apply here a tensile force, then it would be a tensile stress. Okay? And what is the equation of the tensile stress? Hello? F over A. It would be
F over A po.
the area. Correct. Okay, so you are given here the tensile force. Okay, and then ano po yung area? Since you have your other circular cross-section, then that would be pi d
Pi d
squared
squared over
divided
4
by
po.
4. Okay, correct. And then what we will do is to simply equate the sigma d with the sigma t. Okay, so you equate sigma d with the value of sigma t, and then you can compute for the value of the diameter. Nakuha po ba kung paano siya gagawin? Hello?
Yes po, ma'am.
Okay, so you try solving it po. Okay, so try solving it po. Okay, so you are to equate, ari po, okay, yung factor safety po natin is to be incorporated. So, you equate that to. Kung ano po yung maging answer natin dito, siya po yung i-equate natin to this, which is equivalent to force divided by the area. And then you find the diameter. Okay? Kindly express po your diameter in millimeter. Okay? So, express po the diameter in millimeter. So, you use po the same, okay? You use po the same Jamboard po for your solution for this problem po. Ano po yung ating naging answer? Hello?
67.2
Again?
67.216 millimeter po.
Okay, correct. Okay, so 67.216 mm. Okay, so yung iba po, okay, kindly check on how you would obtain this value. Okay, so may question po ba tayo dito? Hello? Wala na po. Okay, so sige po. Okay. So, that ends po yung ating module 4. Okay, so this refers to all mechanical properties po no material. Okay, so we have the different mechanical properties plus the use of this design stresses and the factor of safety. Okay, so kung wala na po tayong question, okay, I'll end po yung aking na presentation. And then, for the remaining hours po, okay, so i-load ko po yung class activity number 3 po natin, which will be under po no mechanical properties. Okay, so you have to solve problems on the mechanical properties. Okay, so yun na lang po yung gagawin natin to be submitted po, okay, on our next face-to-face class. Okay, maliwanag po ba yun?
Yes po, ma'am.
And then, isa pa po pala, yan, yung nakaabuti na alala ko, you have submitted to me po our activity, class activity number 1, which is the comparison, okay, of yung different cola packaging. Okay, tama po ba? Lamang po, okay, so it is submitted po to our classroom. Lamang napakalaki po nung kinain niya na na yung sa storage po, okay, since malalaki po na files yung napa-upload, okay, so ang gagawin na lang po natin, hindi ko po ma-upload yung ibang mga module kasi almost mapuno na po yung akin na storage. So ang gagawin po natin, kindly print po, okay, so you have the option po to print po this activity number 1 and then i-submit na lang po din sa akin during our face-to-face class. Or, okay, or po gumawa na lang si Miss yung po ating coordinator, si Miss Janela, nung link po wherein you could transfer po yung lahat nung submission nyo noong para sa activity 1. Tapos yun po yung i-forward sa akin. Because I will be deleting po on my drive yung pong submission nyo doon. Okay? Para po ma-upload ko yung module 3, 4 natin, okay? Doon sa classroom po. Okay? Naintindihan po ba yung sinabi ko?
Yes po, ma'am.
Okay, so yun na lang po. So, ano na lang po, ibigay na lang po sa akin yung choice whether you will be reprinting po iyon or yun pong link na lang ang ibibigay niya sa akin. Pero, ano nyo po na mamaya po, i-delete ko na po yun para po i-upload ko po yung module 3 and 4. Tama po ba? Yung 3 nga po ba, hindi pa rin naka-upload sa classroom po natin? Pa-check po ako. Makiki-check naman po.
Hindi pa po, ma'am.
Okay, so 3 and 4.
Wala pa po.
So, yun po yung ilalagay ko once na ma-delete ko po yung inyo pong activity number 1. Okay, but then, make sure muna po you have yung copy, okay, para po ma-print ninyo or ma-transfer po ng drive. Okay, so, let me know muna po kung nagawa nyo na po yun bago ko po i-erase at i-upload yung 3 and 4. Okay? So, may question pa po sila. May question pa po?
Ma'am, bali yung pong link po ng drive po na pag-upload na namin, isa-send ko na lang po sa inyo sa messenger po.
So yun na lang. Hindi na tayo magpe-print?
Apo.
Okay. Sige, anak. Okay. Sige, doon na lang. Tapos, pag once na send mo na po yun sa akin, tsaka ko po i-erase yung activity 1, tapos saka po rin i-upload yung dalawa pong modules. Okay? So, again, you work on class activity number 3. Okay? So, yun po yung ilalagay ko ngayon. You work on those particular problems. Okay? So, same format po yun doon sa yung mga previous activities. Okay? So, same format lang po. So, kung wala na po tayong question, ano po na tayo ng attendance po. You open your camera, please. Sino man? Si Mami Aile? Yes. Yun na ba yun? Or percentage lang? Okay. Sino mag-take ng screenshot? Si Van ulit? O ikaw na, Miss Janela?
Sila na lang po ulit.
Sige.
Naka-phone lang po.
Okay. Okay. Okay, thank you. Salamat po. Okay. So, saan yun lang po sa classroom. Okay, yung pong activity 3. Bye-bye.
Thank you po.
Thank you po, ma'am.
Thank you po, ma'am.